All right, we're going to do the diagram of the layers of the earth. So what you need, boys, blank piece of paper. And it would also be helpful to maybe have this diagram out that we did yesterday, this table. Has some information on there that we'll include. Okay, so some of you, do you all have college rule, or some of you have wide rule? Okay, well, if you have college rule, kind of go down 1, 2, 3, 4 lines, and maybe in from the red line a little bit, and just put a dot. Okay? There's less lines on wide rule. And then from the bottom center, you're gonna do the same thing. About 1, 2, 3, 4, and put a dot. And then there's this line over here. Go in a little ways as well and put a dot. Well, you can just estimate the dots, no matter what your paper is. Look at mine and kind of estimate the spatialness for your paper on where they are, okay? This might be the only time you need a ruler, but you could also just use a straight edge of a book or something, and you're going to connect the dots.
Wait a minute, Dave.
Okay. You will have a piece, a little slice of the inside of the earth.
Okay.
And we're going to label the parts.
Is it a piece of cake or a piece of pie?
Piece of pie.
It's a piece of pie. Where are the rulers? There's only a broken one left.
You can use mine. Okay, if you have this part done, go ahead on the top of your pie slice and maybe add a couple of mountain peaks, there, just to add some depth. I don't know, mine aren't very great. And then you might want to dip below the continental crust and do a little bit of oceanic crust here.
Or you could make it simple.
All right, on this side, we are going to list what we call, guys, it'll be up here, the mechanical layers, which will be based and organized on all the physical composition and features of the earth. On this side, if you'd like to do it in a different color, you can. It's going to be the composition layers. And these labels will focus more on how they're organized chemically, okay, the chemical features. We've already talked in a previous unit about the physical properties, chemical properties, and so we're kind of going to go with this organization here. Yeah.
Wait a minute.
Yeah. Can you guys see that okay? You zoom in a little bit on the... There you go. Yep. I will go slowly. It's, if you don't have blue, you can use another color. That's fine. Now on this side, the layers are organized by their chemical features. So this is the crust. We're going to put the crust over here. And of course, the crust includes what? All the way from the top of the mountain to the ocean. Okay? And our crust has two different types of crust. The oceanic and the, what's the other type of crust? Does anybody remember in their reading? Julia? Well, that's over here, physical layers. The lithosphere also includes the crust, but there's two types of crust: oceanic crust and Aiden? Not mountainous, but it's Emma?
Oceanic?
Nope. It is continental. Okay, so the continental crust is going to be the crust that the one that you're standing on, right? The rocks, the mountains, that stuff. And then below the sea, the oceanic crust is below the sea. Makes sense? Below the sea, it's oceanic crust. The crust in the ocean is mainly made of basalt. The oceanic crust is made of basalt. So let's write basalt, B-A-S-A-L-T, and that is mainly going to be ocean, okay? You can put that in parentheses to remind you that's the other makeup of the crust. Look at your layers of the earth. What was the other rock that mostly the crust was made of? Only 3 people? Emma? Granite. Granite was the other one. And that one you're going to find mostly on the continental crust. Okay. Continental. In our layers of the earth lab yesterday, it said the lithosphere was about 200 kilometers, right? So let's go ahead and talk about the lithosphere a little bit. And that is organized over here under physical layers. So go ahead and write lithosphere. Now the lithosphere includes not only the crust, but also what? The very top part of the mantle, right? So that's a little bit more. So if you separate the two, the crust is technically 5 to 70 kilometers, but the lithosphere, because it includes part of the mantle, is going to be a little bit more, right? Okay. But we're going to put the crust measurement there. All right. I am going to do some coloring. I'm going to color my ocean here blue. And you guys can fill in colors if you want. Yeah, and I'm going to do my continental crust, my mountains brown. And I might also color in the word crust brown just to represent. And I will also probably do the lithosphere in brown as well, just so we know. Okay, now you have all heard of plate tectonics, right? So So our Earth is divided into different plates. The plates are the lithosphere. They're made up from the lithosphere. Make sense? Because that's the top crust. Are we good to go, or do you want me to pause while you fill everything in?
Pause.
All right, pausing.
Isn't there supposed to be a little crust under the oceanic?
Yeah, that would be part of the lithosphere under the ocean as well, made of basalt. You can lower it down a little bit if you'd like. I was going to add an extra feature in there, but I'm not doing it yet. Okay. So here, are you to that part now?
No.
As you're drawing a little bit of lithosphere under the ocean, I want you to make it go down a little bit like this. Okay. There's a reason for that, which we haven't studied yet, but we're going to get into that in a minute. Oh, next week. I'm going to dip down in here. Okay. A little preview term. This would be called subduction right here, happening. I'm going to outline that in, yep, I'm going to outline that in black. Or pencil, whatever you have. Just kind of disappears eventually. All right. Beautiful. If you are someone who's done and you want to put a title while you're waiting, you can go ahead and put a cool title, Layers of the Earth. Okay. From the bottom of your oceanic crust, we're going to count down about 10 or 11 lines, okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's do 11 lines and put a line here. Okay. What's that? Just kind of visualize it as a whole, I guess. Let me zoom out if you have wide rule. So this will be the whole paper.
How many lines did you do?
I did about 11 lines down, 10 or 11. From the bottom of the ocean.
I kind of put a little air around my trench knowledge.
And then from there, I'm going to do about 1, 2, 3, 4, 5, 6, 7 lines down and draw a line.
That was my ocean right there.
All right, so there is kind of a split there. All right, so we have the crust. And so the next label from the crust would be this section here, which is called the mantle. So write mantle. And the mantle extends all the way from the bottom of the crust through about right here. Okay? I'll just do that. The mantle, and everywhere I look, our textbook, online resources, that activity we did yesterday, always give a different number for the thickness of each layer. So I'm going to go with the book, and the book says the mantle is about 2,867 kilometers. Okay, thick. I'll zoom in on this again. Did everybody get their lines drawn? And what is the mantle? Yesterday it was said made of periodotite, but that is just a combination. It's a lot of silicate. So write silicate with a combination of magnesium, and some iron. So you can write that in there. How did we spell that? I don't even have that in front of me. Peridotite. There we go. So that's what the mantle is made of. Now the mantle is split into 3 layers. Okay, one layer of the mantle is the bottom part here of the lithosphere, right? So I'm gonna take, I should take black. So we've got right about here is where that mantle is starting to start. Okay. And then, so from here, let's say to about, we can go from 1, 2, 3, 4, let's go to about 4 places. From the bottom of the lithosphere to about here is what we call the asthenosphere. That's a long word. Hard to pronounce, asthenosphere. So on your paper, maybe you just draw a dotted line showing that that's one split layer. That's the asthenosphere. Part of the mantle. So while you're coloring in, let's make the mantle orange, like it was yesterday. Mantle can be orange. So the asthenosphere's part, the mantle, we'll make that orange. You can even color part of the lithosphere in orange just to remind yourself. And then this whole layer will be orange. But it goes all the way down. All right, so tell me, the lithosphere, is it a liquid or a solid? It is solid. Might be important to write. It is solid. Okay, the asthenosphere, is it liquid or solid? Nope. It's not a liquid and it's not a solid. It is kind of a what? A soft solid, and they call that plasticity. It's like plastic. It's very moldable and movable. Yes, Gage. So write it as just write plastic and just put kind of like a soft solid, okay? So it's movable. It's movable. Now, because it's movable, the movements inside the asthenosphere are something that you've seen before. What am I doing? I am drawing what? Convection currents. There are convection currents inside the asthenosphere. Draw those in there. So that soft plastic is very movable and it moves very slowly, but there's those convection currents that move. Yes. Asthenosphere. I think this lithosphere is extending down here. It's not exact. They kind of run into each other. The borders between those layers are, it's like those transition points. So this is kind of a transition point. So the lithosphere is solid, but right underneath it is this plasticky, soft magma. It's still, you could still stub your toe on it, right? But it moves slowly with the heat in a convection current. Hot, cold, hot, cold. And we're going to get into this later, but do you see how this movement moves the lithosphere and somehow pulls some of the earth down into it? And those are what we call the subduction zones. Those cause volcanoes. Those cause the plates to move. This is just a preview of what we're going to be talking about next week. But I wanted to put it on this drawing as well, just to have that there. Okay, so then what's the last part of the mantle called? In the book, it's just called the lower mantle, but let's refer to it as the mesosphere. And the mesosphere is back to a solid again, okay? It's okay, it's all up here. Get darker. How are we doing? I will slow down once you guys get caught up. It's a lot of information. Now, I think I showed this class with the salt, right? Yeah.
You didn't show us the one that you took on like one of the national parks.
I did not. This one, oh, not too bad.
I think so.
This is what the ocean is mostly made of, is basalt. This one is more of a continental crust from a volcano in Yellowstone. And this is a granite.
Yeah.
This is much heavier.
Can I hold it?
So I'll put that. Alright. You have a piece of this.
Can I touch it?
No, I don't have a piece of the sun. That would be cool. Not right now.
Cooper, no English.
All right. I'm going to move down to the next layer, which is going to be the core. So these two together, from here all the way down to, let me can't see it, let me move it down. The bottom is just one big layer, and that is the core. Yes, and the core is split into two different layers. From here to here is the outer core. And then from there to there is the inner core. All right, let's talk about the cores. And let's put some color to it just so we can know. What is the core made of? Charlotte, yeah. Iron and nickel. And both the inner and outer are made of iron and nickel. They have found traces of, I'll add them to this, uranium and what we call and thorium.
How did they find traces of that when it can't
Right? I don't know. Well, you know, they have the advanced scientific stuff.
Technology.
In total, the outer and inner cores about what distance in kilometers? Numbers from yesterday. Cooper. Is about 3,400. And if you put it exact in the book, it's about 3,482 kilometers. Okay, together. Separate. What? I haven't done colors yet. I'm just labeling this so the outer core is a little bit bigger, and that is 2,266 kilometers, and the inner core is 1,216 kilometers. Okay. So the outer core will be the color red. I'm going to go ahead and zoom in on just the core. Hopefully you guys are done with the mantle. So you can see a little bit better. Is that better? Okay, so my outer core is going to be red and my inner core is going to be yellow. Outer core. But how about down here, we just make the whole thing red. Okay, the core red. Yeah, we'll just make it all red. That works. You could go like this. So you can have a separate, so you know the distance is separate. You want to set them apart a little bit. Okay. My red does not look very red.
Almost like brown.
Uh-oh.
Blue?
Okay, I'm going to pause for a minute, but I have a bunch more information to write on here. Not a bunch. Okay. Is the outer core solid or liquid?
Liquid.
Yes, the outer core is a liquid. And inside that liquid, there are some currents called convection currents. Yes, so you're going to need to draw there some convection currents inside our liquid outer core. They are big convection currents.
Wait, I still have to.
Is our outer core liquid or solid?
I don't know. You mean our inner core?
That's sorry. Outer core is liquid. What's our inner core? Solid. Now it goes back to solid. No, iron solid. Get it? All right. Okay. So we kind of go solid, soft, solid, plastic, movable, solid, liquid, solid. All right. Do you have a totally different color you can use? Like I'm going to pick up a green right now and add some notes on here that are really important.
That's smart. I'm gonna add trees.
No, you're not adding trees. Okay. The outer core, with the movement of the convection currents, cause something really important creates for our Earth. It creates what? When you were reading, did you pay attention to what those movements in the outer core created along with the inner core? America. Nope. It created the Earth's magnetic field. Okay, so those movements in the outer core creates the Earth's magnetic field. That's why we have a North Pole and a South Pole. If you're going out with a compass and you walk around, it's going to point where the magnetic field is pointing north based on the movements in our outer core and inner core. Okay, the inner core, this is an interesting fact, spins faster than the rest of the planet. So part of the spinning of the inner core doesn't match up with anything else spinning, and this movement of fluids in the inner core is what works together to create our magnetic field. It's actually quite fascinating.
Doesn't it also turn a different way in the earth?
I'm not sure. I've heard that, yes. I would have to double check that. Yeah, I think you're right. Hey, in total, from the crust all the way to the core, what's the distance?
Was it like 12,800? Yes.
Yesterday, you were given 12,800 as a diameter, but the diameter is not from the crust to the center. You have to half it. So it's about 6,400 from the crust here. The exact number I have is 6,355, but that is just about 6,400. So if you want to write that, you can. Okay. That is it. Isn't that perfect timing? No. So let's look at the big picture of it. Make sure you add the color you need to add. It looks beautiful, doesn't it?
No. Yours does. Mine is even more beautiful. Yeah. If someone wants to be blinded to look at me.